Hi boys, we're going to be looking at equation word problems involving ages. Now these questions require a special technique for some of them. We're still going to apply the same method, but there is a little bit of setting out for some of these which is a bit different. So let's have a look at the first question. It says Justin is 6 years older than his sister Chelsea and their mother is 3 times Justin's age. Part A says if the sum of their ages the sum of the three ages is 79. Write an equation to find Justin's age. Okay, so we've got to find Justin's age. That's what we've got to find. Okay, so we're going to call Justin X. Okay, now let's write down the three people. So Justin, and then we've got Chelsea. And then we've got the mother. Now, with these three questions, we want to use just one pronumeral to define everybody's age with. So if you say Justin is X, okay, because that's the age we're trying to find. Now it says Justin is 6 years older than his sister Chelsea. That means Chelsea is 6 years younger. That means Chelsea is X minus 6. Okay, so if Justin is 6 years older, that means Chelsea is 6 years younger. So she's X minus 6. Now, the mother is 3 times Justin's age. So if Justin is X, the mother's age must be 3X. Okay? Now, next part of information we're given is the sum. It says the sum of the three ages is 79. So these three ages here total 79. So now we can write down an equation. We can say that the sum, so adding all the ages, X plus X minus 6 plus 3X equals 79. 100% hippie. 5X plus 6 plus 6. So we get 5X is equal to 85. And then divide both sides by 5. Cancel. Cancel. And then work out 85 divided by 5. 5 and 8 goes 1. And then 17. Okay. So Justin's age is 17. But it says, now we've got to check because part B says, so we did part A, we wrote the equation, but it says solve the equation to find each person's age. And we found Justin's age to be 17. Okay. So for part B, I'll say Justin is 17. Chelsea will be 6 years younger than that, 11. And the mother is 3 times Justin's age, so it's going to be 51. Okay, so there's question 4. All right, so make sure all that is written down. And now we're going to look at question 5. All right, now it starts off by saying Jennifer is 7 years older than Amy. 10 years from now, the sum of their ages will be 43. How old are they now? Now, there's a specific way of setting this out, which is going to be helpful. So we're going to start off with Jennifer. So we're going to write down the names again, just like before. And then we've got Amy underneath. And we're going to do a little table. You'll see why this is going to help us. Okay, now we're going to do their age now, and then we're going to do their age in 10 years' time. Okay. Ten years later. Okay, so let's start off with now. It says, now Jennifer is 7 years older than Amy. All right, so if we call Amy X, then Jennifer will be 7 years older than that, X plus 7. All right, now 10 years later, Amy will be X plus 10, and Jennifer will be 10 years older as well, so it should be X plus 17, right? Because adding 10 to X plus 7 gives you X plus 17. Now, that's how old they are in 10 years' time. Now, it says the sum of their ages will be 43 after 10 years. So 10 years from now, the sum of their ages. That means the total of their ages after 10 years is 43. Okay, so that's going to be the column in the table we're going to use to get our equation. So we're going to get X plus 17 plus X plus 10 equals 43. So let's write that down. So X plus 17 plus X plus 10 equals 43. So it's going to give us 2X plus 27 equals 43. And then we're going to minus 27 from both sides. So it's going to give you 2X is equal to 16. And then we're going to divide both sides by 2. Divide both sides by 2, you're going to get X is equal to 8. Okay, now have we answered the question? Let's have a look. It says, how old are they now? Now, this is their age now. Amy is X and Jennifer is X plus 7. So we've got Amy's age now. Amy is now 8. So now, okay, Amy is equal to 8. Okay, and Jennifer is equal to 8 plus 7, which is 15. Okay, so that's the answer to that question. Now, there will be some of you who are really good at crunching the numbers, and you'll be able to work out the answer without doing any of the algebra, which is really good. But certainly in the assessments, we are looking for an equation. And in fact, we'll structure the question which says, write an equation down. So in the questions in the textbook, you're expected to solve these by using equations and not by crunching numbers on the calculator. So if you just work out the answer without any algebra, you'll be asked to do the questions again. Now, I just want to go back to the previous question, because when you're doing the algebra for these questions, it is often possible to do them using different algebraic expressions. So I'm just going to rub out the answer here for B just for a minute. I'm going to show you there's another way of solving this, because some of you will do it this way in the examples. Now, let's just say that in the beginning, you said Justin is 6 years older than his sister Chelsea. So let's just say, so I'm going to put down or here. This is another way of doing it, or. Let's just say for Chelsea, you said that she was X instead. If Justin is 6 years older, then you could write down that he is X plus 6. Okay, let me just fix that 6 up there. Okay, so X plus 6. Now, the mother is 3 times Justin's age, so that's 3 times, and you have to have the brackets here because you've got 2 terms in multiplying. Okay, Now, when you go to write your equation, you're going to add those three terms together. This will be your equation. It'll be x plus 6 plus x plus 3 lots of x plus 6, and that's the sum of their ages is equal to 79. Now, when we go to solve this equation, we should get the same answer as we did with the pink equation. So let's just expand the brackets first. Actually, got x plus x is 2x. So I'm going to have 2x plus 6. Plus, I'm going to expand this bracket. So it's going to be 3x plus 18 equals 79. And then I've got 2x and 3x is 5x plus 24 is equal to 79. So minus 24 from both sides. And you should get 5x is equal to 55. And then dividing by 5, you're going to get x equals 11. Now, some of you will be saying, yeah, but you got a different answer. Well, we did because we had a different equation. But when I work out the ages of the people, so let's have a look. In my answer here, x is 11. Now, if x is 11, okay, if x is 11, then Justin is 17. So I'll write down Justin equals 11 plus 6, which equals 17. So if I come back down to my previous answer, I had x is 17 and x was Justin's age in my first one. So in actual fact, we did get the same answer there. Okay, so Justin's age is 17, and I worked out in the second equation Justin's age is also 17. So in that first question there, you could have written down two different equations, right? Now you'll get a different answer in the equation, but when you go back to substitute those values back into the algebraic expressions for their ages, you will get the same answer. Okay, so Chelsea, right, she'll be 11 minus 6, which is 5, and then the mother, when you put 11 plus 6, you get 17. She'll be 51. So how does that work out? X is 11, not 5. My bad there. So I'll just go back there. That should be, just see that I've made an error. All right, so this here, yeah, so Chelsea's age in the second equation is x, and I found x to be 11, so Chelsea is 11. There we go, that's better. So I've got the same numbers as the previous one. So often there's more than one way of writing the equation. Okay, that's it for today.